All right, let's get right into it. We're going to pull back the curtain on the hidden front lines of the 21st century. I'm talking about the invisible infrastructure that underpins, well, pretty much everything you do.
Just think about your day. That credit card swipe for coffee, the map app that got you here, global finance, national defense. Every single one of those things relies on two huge, complex systems that are almost completely invisible to us.
These are really the two pillars holding up our modern world. The first is this constant, whisper-thin signal coming down from satellites, giving us a universal clock that's accurate down to the nanosecond. The second, it's a massive river of data, the actual lifeblood of the internet, flowing through glass fibers thinner than a human hair, stretched across the ocean floor.
For about half a century, we built our entire global economy on this quiet, unspoken assumption that these systems would just, always be there, always work. Well, that assumption isn't safe anymore. The era of taking our invisible world for granted, it's over.
So, let's start way up high, in the sky, where the first crisis is already happening, and it's all about something we thought was rock solid: the surprising fragility of global positioning.
The tech we're talking about is called PNT, positioning, navigation, and timing. We all know it as GPS, right? But the secret ingredient, the real superstar here, is the T for timing. That incredibly precise time signal is what synchronizes our cell networks, it guides massive cargo ships, and it timestamps trillions of dollars in financial trades every single day.
And this slide right here, it really nails the core of the problem. We used to assume that these signals, beamed from 20,000 kilometers away, were a constant utility, always on. But the new reality? It's way different. By the time a GPS signal actually reaches your phone, it's weaker than the background radiation of the universe. I mean, it is frighteningly easy to block with simple jammers or, even worse, to hijack with fake signals in an attack they call spoofing.
So what happens if it fails? What's the cost? Well, a UK government study figured out that just 1 week, 7 days without these PNT signals would cost its economy £7.6 billion. So we're not talking about a minor inconvenience here. This is a catastrophic threat to our whole economic and security setup.
Okay, so we've looked at the crisis in the sky. Now let's dive deep, literally, into a shadow war that's brewing beneath the waves. Because PNT gives us our sense of time, but the actual data, the internet itself, flows through a network that's just as vulnerable.
Just look at the scale of this thing. We're talking about 1.4 million kilometers of submarine fiber optic cables. That's enough to circle the Earth 35 times over. This is the physical internet. It carries 99% of all international data and moves over $10 trillion in financial transactions every single day.
Now here's what's really wild: the sheer mismatch in scale. To maintain and repair that entire planet-spanning network, the whole world has a fleet of only about 70 specialized cable repair ships. 70. That's it. That is a shockingly tiny number for a job this critical.
And that problem? It's about to get a whole lot worse. That tiny fleet is getting old. By 2040, nearly 2/3 of these vital ships will be past their 40-year operational lifespan. Think about that. That creates a massive maintenance bottleneck right at the moment our hunger for data is just exploding.
And this physical weakness is now being actively exploited. There's a new kind of conflict called gray zone warfare. These are hostile acts that are deliberately designed to look like accidents. It's basically sabotage with plausible deniability baked right in, a way to hurt your adversary without ever firing a shot.
The Baltic Sea has pretty much become a live fire laboratory for these tactics. In October 2023, this ship, the new Polar Bear, somehow drags its anchor for over 100 miles, ripping up a gas pipeline and 2 data cables. A year later, you have similar incidents with other ships. In every single case, it could be a freak accident, or it could be a deliberate test of Western defenses. And proving which one it is? That's almost impossible. Okay, so we're facing threats from the sky and from under the sea. What do? Well, the world has kicked off a frantic race for resilience. And the solution isn't to build one single, perfect, unbreakable system. No, it's to build what they call a system of systems, with multiple overlapping layers of defense. This new architecture is built on 3 main layers. First, you go back to the ground with a powerful, sovereign backbone. Second, you build a new, much more robust layer of satellites, way closer to Earth. And third, you take a genuine quantum leap, developing technology that can navigate without any external signals at all. So for this first layer, the key is just raw power. A terrestrial system like Eloran uses these massive ground-based towers to blast out a signal that is literally 1,000,000 times stronger than GPS. It's incredibly hard to jam, and it can even work indoors or in shallow water where GPS just can't penetrate.
Now that second layer is a whole new generation of satellites in low Earth orbit, or LEO. And just because they're so much closer to us, their PNT signals are about 1,000 times stronger than the old-school GPS. That gives them a kind of natural, brute force resistance to the cheap, low-power jammers.
And this isn't science fiction, you know? A new space race is already happening. Companies like Iridium, Zona Space, and TrustPoint are building out this new orbital layer as we speak, and they're all taking a slightly different approach, from encrypted signals to using different radio bands, all to fight back against jamming and spoofing. But the final layer, the ultimate backup plan, is easily the most revolutionary. Quantum navigation is a total game changer. Like this quote says, instead of passively listening for a faint signal from far away, these systems navigate by directly measuring reality itself.
And the precision is it's mind-boggling. I mean, look at this table. A classic clock might drift by a nanosecond a day. A new quantum clock drifts by less than a picosecond. That is 1,000 times better. What that means is a submarine or a drone could go completely dark, no external signals, for weeks, maybe even months, and still know its exact position down to the meter. It's the ultimate fail-safe.
So what happens when this kind of revolutionary tech starts to spread around the globe? Well, of course, it leads to a brand new geopolitical contest. Securing this invisible infrastructure is now a top priority for any major world power.
And you can see it right here on this slide. The race is definitely on. China is building this massive LEO constellation to achieve what it calls digital sovereignty. Japan is launching its own system to get rid of GPS reliance in its super-dense cities, and the US is going all in on what it calls assured PNT to guarantee its national security.
So at the end of the day, the big takeaway is this. We have entered a fundamentally new era. Our most important infrastructure is no longer something we can just build and then forget about. The future is this complex, hybrid system of systems that has to be actively and constantly defended.
Which leaves us with one last big question. When the most important battlefields on the planet are completely invisible, hidden in orbit, or buried deep at the bottom of the sea, what does it actually mean to be secure?